This question is asking about the twofold cross-validation accuracy using the majority classifier. So we know that majority classifier is also the k-n, the k-nearest classifier with k larger than or equal to n being the number of instances in the training set. But in any case, it's just predicting the majority of the training data label. So what I mean by twofold classification, I'll actually solve the example for fivefold cross-validation. So it means I will divide the data set into 5 parts and using each part as the test set. So the first fold will be using this as the test set and using the remaining ones as the train set. So we'll be training our y hat on this set, which means y hat will be there are 5 zeros and 3 ones. So the mode will be 0. So after the training, y hat will always predict 0. And when it's actually applied on this test set, this will be classified wrong, and this will be classified wrong. So the training set accuracy here is 0, so nothing is classified correctly. The interesting case is this. So when this happens, there are 4 zeros. So we're using the remaining set as the training set. So there are 4 zeros and 4 ones. So in that case, if it's not stated clearly, we will assume that we are predicting 0 half of the time and 1 half of the time. So if that's happening, then 0 is, so this is predicted correctly half of the time, and this is predicted correctly half of the time. So in total, there will be one of these two, in any case, will be predicted correctly. So either this one or this one. And if you want to make some assumption, it's okay too, actually. So if you want to say if they are equal, then I always pick one. That's okay too, because you'll get this correct and this wrong, which the total is actually the same. So in any case, one of these will be correct, 0 of this will be correct, and one of these will be correct, and also one of these will be correct, and 0 of these will be correct. So there are in total 3 out of 10 that will be correct, because there are 10 data point in total. 3 of them are classified correctly. No matter how you interpret this majority classifier in the case of a tie, in both cases, it's just 3 out of 10, so the percentage is 30%.